Hi everyone, welcome to Numeric Learning. So in today's video, let us do some important questions from the unit real numbers as a part of our daily practice. So the first question is, find the largest number which exactly divides 280 and 1245, leaving the remainders 4 and 3 respectively. So you have to find a biggest number which exactly divides two numbers, and those numbers will be obtained if you subtract the given number minus the remainder. The given number minus the remainder. So let's find out which are those two numbers. The first one is 280 minus its remainder, which is 4. So you'll be getting 276. And the second number is 1245 minus its respective remainder, which is 3. So you'll get 1242. So you have to find a largest number which exactly divides these two, that is 276 as well as 1242. And whenever you have to find the largest number, you will have to take the HCF, highest common factor, of 276 as well as 1242. And the method with which we can do is the prime factorization. So let us take the prime factorization of 276. So 276, start with the lowest prime number, which is 2. So 2 ones are 2, 2 threes are 6, and then 2 eights are 16. Right? Again 2, 2 6 are 12, 2 nines are 18, and then 3, 3 twos are 6, 3 3, and 23 is a prime number. And then 1 2 4 2, start from the lowest prime number, that is 2, 2 6 are 12, 2 2s are 4, 2 1s are 2. Okay, and then let's go with 3, 3 2s are 6, and then 0, 3 7s are 21. Again 3, 3 6 are 18, again 3 9s are 27, again 3, 3 2s are 6, 3 3s are 9. Okay, so the prime factorization, of 276 is nothing but 2 square multiplied by 3, and 1242 is nothing but 2 multiplied by 3 cube multiplied by 23. Here also you have 23. So in order to find the HCF, you will be taking the lowest power of the common factor. What is the lowest power of 2? Here it is 2 to the power 1, here it is 2 to the power 2. Which is the lowest power? It is 2 to the power 1. So 2. For 3, what is? So here you have 3 as a prime factor. One of the power is 3, the other one is 1. You have to take the lowest power. So 3 to the power 1 and 23. Right? So here you will have 6 multiplied by 23. 3 2s are 6. So 6 3s are 18. 138 is the correct answer. So 138 is the largest number which divides 276 and 1242 perfectly. So 276 divided by 138, you will be probably getting a 2. Okay, and if you divide 1242 divided by 138, again you will be getting a whole number. But if you divide this 280 with 138, it will leave a remainder 4. And if you divide 1245 divided by 1338, it will leave a remainder 3. So whenever such questions are asked to find the largest number or the biggest number which exactly divides any two given numbers, leaving the remainders, then you will have to subtract the given number with its remainder. The given number with its remainder. That's the first thing that you have to do, and then you go calculate the HCF. Okay, so this is how you have to proceed, and this is a very, very important question. You could be asked even a set of 3 numbers, leaving the remainders, three different remainders. So the first thing that you have to do is subtract the given number with the remainder. Given number with the remainder, get the actual number for which you have to find the HCF. Okay, so this is how you have to proceed. Right, so the answer is 138. Let's move on to the next question. If A is nothing but 2n plus 13 and b is n plus 7 where n is a natural number. Find the HCF of a and b. So here n is given as a natural number. So well, let's replace n with 1. Then what will be a? A will be 2 into 1 which is 2 plus 13 that is 15. And what will be b? B will be n as 1. We have taken n as 1. Right? So b will be 1 plus 7 which is nothing but 8. Let us do the prime factorization. So 15, the prime factorization will be 3 into 5. And for 8, the prime factorization will be 2 cube. Okay, so what I'm going to do, I'm going to change, make sure all the factors are common across. So here it will be 2 to the power 0. Here I'll write 3 to the power 0 and 5 to the power 0 to make sure 2, 3 and 5 are the common factors. Now, find the HCF. So, the HCF of 15 and 8 will be, take the lowest power. So, it is 2 to the power 0. For 3, it is 3 to the power 0. For 5, it is 5 to the power 0. So, the answer is 1. So, what is the HCF of A and B? It is 1. Okay. So, this is how you have to do it. Always remember, whenever you are given any term or any number with a variable in it, n is a variable and you are given n is a natural number, just substitute n with the natural number. So, natural numbers are counting numbers which begin with 1 and it goes on up to infinity. And you can replace n with anything else. You can even replace n with 2 and then go ahead and calculate it. Okay, find the HCF. Let's move on to the third question. The total number of factors of a prime number. What are prime numbers? Prime numbers are those numbers which have only 2 factors. Prime numbers have only 2 factors. Okay, 1 and the number itself. For example, you have 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, and then 11 is a prime number, 13 is a prime number, and so on. So these numbers have only two factors, 1 and the number itself. So always remember, the number of factors of a prime number is always 2. Okay. And if in case if you have a number that has more than 2 factors, then they are called as composite numbers. Composite numbers. Any number that has more than 2 factors. Okay, for example, you have 4. What are the factors of 4? 1 is a factor, 2 is a factor, 2 2s are 4, and then 4 is a factor. So you have 3 factors, right? More than 2. Any number which has more than 2 factors, you call it a composite number. Okay. Okay. Now let's move on to the fourth question. Find the HCF and LCM. Okay, so here there's something missing. And LCM of 12, 21 and 15. First of all, let's do the prime factorization of 12. So 2 6 are 12, 2 3s are. So the prime factorization of 12 is 2 square multiplied by 3. For 21, it is 3 multiplied by 7. And for 15, I know it's 3 multiplied by 5. Now let me make the factors common. I don't have a 5 here, so I'll write 5 to the power 0, 7 to the power 0. Here I don't have a 2, 2 to the power 0. I don't have a 5, so 5 to the power 0. Here again 2 to the power 0 and 7 to the power 0. This 0 is added so that I can make the powers, the prime factors common. Okay, so now let us calculate what is the HCF. HCF will be, in order to take the HCF, find the HCF, you have to take the lowest power. Okay, let me write it here. Lowest power of the common factor. Okay, so for 2, what is the lowest power? 2 to the power 0. For 3, what is the lowest power? It is just 3. So everywhere, see, you have 3 to the power 1, 3 to the power 1, 3 to the power 1. So it is again 3 to the power 1 is nothing but 3. Lowest power of 5 is 5 to the power 0. Lowest power of 7 is 7 to the power 0. So any number to the power 0 is 1. So the answer is only going to be 3. Okay, and let's calculate what is the LCM. LCM means you have to take the highest power of all the factors. Highest power of all the factors. So for 2, what is highest factor? 2 square. For 3, it is 3. For 5, it is going to be 5. And for 7, it is 7. So let's calculate. 2 square is 4. 4 3s are 12. 12 into 5 into 7. 12 5s are 60. 60 into 7. 6 into 7, it's 42. 6 7s are 42 and add a 0. So this is your LCM. So HCF is 3 and the LCM is 420. So the method that we have used here is called the prime factorization. Why is it called prime factorization? Because any given number is broken down into a product of prime numbers. 2, 3, 5, 7 are all prime numbers. And what are prime numbers? All the numbers that have only 2 factors, 1 and the number itself. Okay, and in the world, any composite number, that means all the numbers that have more than 2 factors, they can be expressed as a product of prime numbers. Okay, and this method is what is called as prime factorization, and prime factorization makes it easier for us to break down any given number into a product of prime factors. And once you have broken it down, it's very easy to calculate the highest number that divides the given, all the 3 given numbers. So if you see 12, 3 can divide 12 perfectly. 12 divided by 3 is 4. 3 can divide 21 perfectly. 21 divided by 3 is 7. 3 can divide 15 perfectly. What is 15 divided by 3? It is 5. And what do you mean by LCM? LCM is nothing but by 12, 21 and 15. Okay, so 12 can divide 420, 21 can divide 420 and 15 can also divide 420 perfectly. Least common multiple, right? The lowest number which can divide, there cannot be a number which is lesser than this 420. The smallest number with which all 12, 21 and 15 is it can divide. All these 3 numbers can divide 420. Okay. Hope you understood. Let's move on to the next question. This is again a very, very important question. In a teacher's workshop, the number of teachers teaching French, Hindi and English are 48, 80 and 144 respectively. Find the minimum number of rooms required if in each room the same number of teachers are seated and all of them are of the same subject. So, in a workshop, you have 48, 80 and 144 teachers respectively. You have to find how many teachers can you make them sit in a single room such that all the rooms contain the same number of teachers and all the teachers teach the same subject. So you cannot have a room which has got say 150 teachers, right? You cannot make 150 or 200 teachers to be seated in a room. You cannot have a number greater than the given number. So in this particular question, the answer is less than the required answer is less than the given data. And if the answer is less than the given data, then it is factor and it is the HCF. You have to calculate the HCF of 48, 80 and 144. So that will give you the highest number of teachers who can be seated in a room such that all the teachers are either belonging to French, Hindi or English. Okay, so let us do the prime factorization of 48. 48, you have 2, 24, 2, 12, again 2, 6 and then 2 and 3. Okay, so it is nothing but 48 can be written as 2 to the power 4 multiplied by 3. For 80, it is again 2 4s are 8, 2, 20, 2, 10 and then 2, 5. So it is 2 to the power 4 multiplied by 5. And for 144, it is nothing but, so 144. So 2 7s are 14, 2 2s are, so 2, 3, 6. Again 2 1s are 2, 2 8s. Again 2 9s are 18 and then 3 3. So it is 2 to the power 4 multiplied by 3 square. Now let us make the powers common. It is 5 to the power 0. Here also you have 5 to the power 0. Here you have 3 to the power 0. So in order to find the HCF, you will be taking the lowest power. So for 2, 2 to the power 4. For 3, 3 to the power 0. For 5, it is 5 to the power 0. And what is 2 to the power 4? 2 2s are 4, 2s are 8, 2s are 16. So you can have 16 teachers be seated in a single room. Now you have to find what is the minimum number of rooms required. Okay, so 48 is for French. So number of rooms required for French will be 48 divided by 16. Right? So you will get 3 rooms. Again, the number of rooms required for the next subject, which is Hindi. Hindi will be 80 divided by 16. Okay, so you will be getting 5. And the number of rooms required for your English will be 144 divided by 16. So what is 144 divided by 16? It is 9. Okay, so this is the minimum number of rooms required. So add up the total rooms. 9 plus 5, 14, 15, 16, 17. So 17 rooms are required. Okay, so what are you asked? Find the minimum number of rooms required if in each room the same number of teachers. So totally you need 17 rooms. This is the total number of rooms required. So all these questions were very important, and we will continue doing this daily practice almost on an everyday basis. So hope you understood. If you are interested in enrolling for an online mathematics class for CBSE 10th, do check the description for details. Comment if you are interested. Do follow my WhatsApp channel for daily problems, and do like, share, and please do subscribe. Thank you. Happy learning.